October 17th, 2024. A sleek experimental aircraft streaks through the upper atmosphere, its titanium hull glowing faintly from the heat of hypersonic flight. Designed to push the boundaries of aviation, this cutting-edge prototype is on a classified test mission soaring at 90,000 feet, higher than any commercial jet dares to fly. Its mission: to test the limits of a revolutionary propulsion system that could redefine air travel forever. But something goes catastrophically wrong. A cascade of system failures sends the plane spiraling beyond its intended altitude, far past the edge of Earth's atmosphere, into the void of space itself. This is the shocking, heart-pounding story of the plane that accidentally ended up in space. A tale of ambition, ingenuity, human courage, and a near disaster that captivated the world. The story begins in the high-stakes world of aerospace innovation. In the early 2000s and 20s, the race to develop next-generation aircraft is fiercer than ever. Nations and private corporations alike pour billions into hypersonic technology. Planes capable of traveling faster than Mach 5, 5 times the speed of sound. These machines promise to shrink the globe, turning transcontinental flights into hour-long jaunts and opening the door to commercial space travel. One shadowy project, shrouded in secrecy, stands at the forefront of this revolution. A coalition of cutting-edge engineers and scientists, backed by a consortium of tech giants and government agencies, unveils a prototype unlike anything the world has seen. Its codename, Aurora X. Aurora X is a marvel of modern engineering. Its sleek, dart-like fuselage is crafted from advanced titanium alloys, designed to withstand the blistering temperatures of hypersonic flight. The plane's propulsion system is its true masterpiece, a hybrid engine that combines traditional jet turbines with a radical new technology, a plasma-based thruster. This experimental system, derived from decades of research into ion propulsion, uses electromagnetic fields to superheat and accelerate air particles, generating thrust far beyond conventional engines. The goal is audacious: to create an aircraft that can cruise at Mach 6, climb to the edge of space, and return to Earth with the ease of a commercial airliner. But such ambition comes with unimaginable risks. The test flight is scheduled for a crisp October morning at a remote military airfield in the Nevada desert, a place whispered about in conspiracy circles as the successor to Area 51. The runway stretches across the barren landscape, flanked by towering hangars and radar dishes scanning the skies. A small team of elite pilots, engineers, and mission controllers gathers in a high-security control room, their faces tense with anticipation. The pilot, a seasoned test aviator with decades of experience flying experimental aircraft, climbs into the cockpit. Clad in a high-altitude pressure suit, the pilot runs through a meticulous pre-flight checklist, each step scrutinized by ground crews monitoring every system. The co-pilot, a brilliant aerospace engineer, doubling as a systems specialist, occupies the second seat, ready to manage the plane's complex propulsion and navigation systems. As the sun rises, casting a golden glow across the desert, the order comes: Aurora X, you are cleared for takeoff. The engines roar to life, a low rumble that builds into a deafening scream. The plane surges forward, its wheels lifting off the runway in seconds. Spectators shield their eyes as the aircraft climbs steeply, disappearing into the azure sky. Within minutes, it reaches its cruising altitude of 90,000 feet, skimming the boundary between Earth's atmosphere and the blackness of space. From the cockpit, the view is breathtaking. The curvature of the planet is visible below, a glowing blue arc against the infinite dark. The sky above, it is a deep indigo, speckled with stars even in daylight. For a moment, everything seems perfect, but perfection is fleeting. At 10:47 a.m., a faint tremor ripples through the airframe. The pilot's instrument panel flickers, and a single amber warning light begins to pulse. Anomaly detected in the plasma thruster, the co-pilot reports, voice steady but laced with urgency. Ground control scrambles to diagnose the issue, their screens flooding with data. The thruster's electromagnetic field is destabilizing, causing erratic surges in thrust. Before the team can react, a second alarm blares. The navigation system is losing synchronization with GPS satellites, likely due to interference from the thruster's magnetic field. The plane, now traveling at Mach 6, is beginning to deviate from its programmed flight path. The pilot grips the controls, fighting to maintain stability. "We're climbing too fast," the co-pilot warns, eyes darting between monitors. The altimeter spins wildly, ticking past 100,000 feet, then 120,000. The plane is no longer flying. It's rocketing upward, propelled by the runaway thruster. Ground control's voices crackle over the radio, their calm professionalism giving way to panic. "Aurora X, reduce thrust immediately. You're approaching the Kármán line." The Kármán line, at 328,000 feet, marks the boundary where Earth's atmosphere ends and outer space begins. No aircraft is designed to operate there, not even Aurora X. In the cockpit, the situation deteriorates rapidly. The airframe shudders as it encounters the thinning atmosphere, its aerodynamic surfaces losing effectiveness. The pilot attempts to throttle down the engines, but the plasma thruster is locked in a feedback loop, generating uncontrollable thrust. The co-pilot frantically reroutes power, trying to stabilize the system, but every adjustment seems to make things worse. The altimeter now reads 200,000 feet, then 250,000. The plane is climbing into the thermosphere, a region where temperatures can exceed 2,000 degrees Fahrenheit due to solar radiation. The titanium hull, designed for hypersonic flight, begins to glow cherry red, its heat shields straining under the unexpected conditions. Back on the ground, the control room is in chaos. Engineers shout conflicting theories while mission directors bark orders. A chilling realization dawns. Aurora X is no longer an aircraft. It's a spacecraft, hurtling into orbit without a plan, without sufficient fuel, and without the shielding needed to survive re-entry. The implications are staggering. If the plane continues its ascent, it could become stranded in low Earth orbit, its crew doomed to a slow death as oxygen runs out. If it attempts re-entry without proper control, it could burn up in the atmosphere, scattering debris across continents. The world's most advanced aircraft is now a ticking time bomb. The pilot's voice cuts through the static, steady, despite the chaos. "We're at 300,000 feet and climbing. Systems are critical. Request immediate abort protocol." But there is no protocol for this. No one anticipated a scenario where an experimental plane would breach the atmosphere. Ground control scrambles to contact space agencies, hoping for expertise in orbital mechanics. Meanwhile, the co-pilot makes a desperate move, overriding the thruster's safety protocols to force a shutdown. The gamble works, partially. The thruster cuts out, but the plane's momentum carries it higher still, crossing the Kármán line at 328,000 feet. Aurora X is now in space. For a fleeting moment, the cockpit is silent. The pilot and co-pilot stare out at the void, the Earth a distant blue marble below. Weightlessness grips them as the plane enters microgravity, instruments floating gently in the cabin. The beauty is overwhelming, but terror overshadows it. The plane wasn't built for this. Its life support systems are designed for short, high-altitude flights, not extended space missions. Oxygen levels are already dropping, and the thermal protection system is dangerously overstressed. The crew has minutes, maybe hours, to act before the situation becomes irretrievable. Ground control regains composure, their voices now a lifeline. Aurora X, we're calculating a re-entry trajectory. Stand by for coordinates. But re-entry is a nightmare scenario. At orbital speeds, the plane will hit the atmosphere like a meteor, generating temperatures hot enough to melt steel. The heat shields, optimized for hypersonic flight, aren't rated for the extreme conditions of orbital re-entry. Worse, the navigation system is still offline, leaving the crew blind to their precise position and velocity. Every second in space pushes them further from a safe return. The co-pilot, drawing on years of engineering expertise, proposes a radical solution. Use the plane's remaining fuel to fire its maneuvering thrusters in short bursts, nudging it into a lower orbit. This could slow its velocity enough to attempt a controlled re-entry. The pilot agrees, and the crew begins the delicate task of manually adjusting the plane's attitude. Each thruster burst is a gamble, burning precious fuel and risking further damage to the overstressed airframe. Slowly, agonizingly, the altimeter begins to tick downward. 320,000 feet, 310,000, 300,000. As the plane descends, the atmosphere begins to bite. The hull vibrates violently, and the cockpit fills with the roar of superheated air. The heat shields glow white-hot, flakes of ablative material peeling away. The pilot wrestles with the controls, trying to maintain a shallow re-entry angle. Too steep, and they'll burn up. Too shallow, and they'll skip off the atmosphere like a stone on water, back into space. The co-pilot monitors the temperature gauges, voice hoarse from shouting updates. Shields at 80% integrity, 70%. Hold her steady. On the ground, the world is watching. News of the incident leaks almost immediately, sparked by amateur astronomers who spot a mysterious object in low orbit. Social media erupts with speculation. Hashtags like number spaceplane and number Aurora X trending globally. Grainy telescope images circulate, showing a glowing streak against the stars. Major news networks interrupt regular programming, their anchors struggling to explain the unprecedented event. A plane in space? One pundit exclaims, "This is science fiction come to life." Governments issue vague statements, neither confirming nor denying the incident, while aerospace experts scramble to piece together what's happening. In the control room, the mood is grim. Telemetry data paints a dire picture. The plane's structural integrity is failing, and its fuel reserves are nearly depleted. Mission directors prepare for the worst, quietly notifying emergency response teams across the Western Hemisphere. If Aurora X breaks apart, debris could rain down over thousands of miles, endangering populated areas. Yet amidst the despair, a glimmer of hope emerges. The crew's maneuvers are working. The plane is now at 200,000 feet, re-entering the upper atmosphere. If they can hold it together, they might just make it. The cockpit is a furnace. The interior temperature climbs despite the cooling systems, and the crew's pressure suits are pushed to their limits. The pilot's hands tremble on the controls, sweat beading inside the helmet. The co-pilot recites system statuses like a mantra, fighting to stay focused. Shields at 50%, navigation partially online. We're at 150,000 feet. The plane's aerodynamic surfaces begin to respond as the atmosphere thickens, giving the pilot a fighting chance to steer. Ground control feeds them a re-entry corridor, aiming for a remote stretch of the Pacific Ocean to minimize risk to civilians. At 100,000 feet, the worst seems over. The plane is no longer a fireball, its speed dropping to Mach 4. But a new danger emerges: structural fatigue. The airframe, battered by the ordeal, begins to crack. A sharp jolt rocks the cockpit as a section of the wing's leading edge shears off. Warning alarms scream, and the plane lurches into a spin. The pilot's training kicks in, countering the spin with precise control inputs. The co-pilot jettisons the remaining fuel, lightening the aircraft to improve stability. "We're not done yet," the pilot growls, determination overriding exhaustion. The world holds its breath. Live feeds from weather satellites capture the plane's descent, a glowing streak over the Pacific. Millions watch, hearts pounding, as the aircraft fights to survive. In homes, bars, and offices, strangers clasp hands, united by the drama unfolding in real time. The emotional weight is unbearable. 2 lives hang in the balance, along with the dreams of a generation of engineers who dared to push the boundaries of flight. Social media overflows with prayers, memes, and messages of hope. "Come home safe," one post reads, shared millions of times. At 50,000 feet, the plane stabilizes. The pilot levels the wings, now flying like a conventional aircraft, albeit a badly damaged one. The co-pilot patches into ground control's frequency, voice cracking with relief. "Aurora X, we're through the worst. Requesting emergency landing coordinates." The control room erupts in cheers, but the danger isn't over. The nearest runway is thousands of miles away, and the plane's fuel is gone. The pilot must glide the crippled aircraft to a safe landing, a feat requiring superhuman skill. Ground control vectors them toward a military base in Hawaii, its long runway the best chance for survival. The plane descends, its battered hull groaning under the strain. At 10,000 feet, the pilot deploys the landing gear, praying it still functions. The gear locks into place with a reassuring thud. The co-pilot runs final checks, shutting down non-essential systems to conserve power. The runway comes into view, a thin strip of concrete against the endless ocean. "This is it," the pilot says, voice steady. "Let's bring her home." The landing is a masterclass in precision. The plane touches down at 200 knots, tires screeching as they kiss the tarmac. Emergency vehicles race alongside, their lights flashing in the dusk. The aircraft rolls to a stop, steam rising from its scorched hull. For a moment, silence reigns. Then the cockpit canopy opens, and the pilot and co-pilot emerge, waving weakly to the cheering ground crews. They're alive. Against all odds, Aurora X has returned from space. The aftermath is a whirlwind. The crew is rushed to a medical facility, treated for dehydration and minor injuries. The plane, now a global icon, is cordoned off for analysis, its charred hull a testament to its ordeal. News outlets hail the crew as heroes, their names trending alongside number Aurora X. Aerospace experts marvel at the feat, calling it a turning point in aviation history. "This wasn't just a test flight," one analyst declares. "It was a glimpse of the future, and a warning of how far we still have to go. Investigations begin immediately, focusing on the plasma thruster's failure. Early findings point to a software glitch that caused the electromagnetic field to destabilize, coupled with a design flaw in the navigation system's shielding. The incident sparks fierce debate in the aerospace community. Some call for a halt to hypersonic research, citing the risks exposed by Aurora X's near disaster. Others argue it proves the resilience of modern engineering, urging continued investment. The public, meanwhile, is captivated by the human drama, a story of two souls defying the cosmos to come home. Social media amplifies the emotional impact. Viral videos show the crew's families weeping with joy as news of the safe landing breaks. A grainy clip of the pilot's final radio call, "We're not done yet," becomes a rallying cry, remixed into songs and memes. The incident inspires a wave of interest in space exploration, with young people flooding STEM programs, dreaming of building the next Aurora X. The plane itself, though heavily damaged, is destined for a museum, where it will stand as a symbol of human ambition and resilience. Yet the story doesn't end with triumph. The incident exposes vulnerabilities in the rush to conquer hypersonic flight. Governments and corporations face scrutiny over the secrecy surrounding Aurora X, with whistleblowers leaking details of the project's accelerated timeline and overlooked safety concerns. Activists demand transparency, arguing that the public deserves to know the risks of such experiments. The aftermath is a whirlwind. The crew is rushed to a medical facility, treated for dehydration and minor injuries. The plane, now a global icon, is cordoned off for analysis, its charred hull a testament to its ordeal. News outlets hail the crew as heroes, their names trending alongside number Aurora X. Aerospace experts marvel at the feat, calling it a turning point in aviation history. "This wasn't just a test flight," one analyst declares. "It was a glimpse of the future and a warning of how far we still have to go." Investigations begin immediately, focusing on the plasma thruster's failure. Early findings point to a software glitch that caused the electromagnetic field to destabilize, coupled with a design flaw in the navigation system's shielding. The incident sparks fierce debate in the aerospace community. Some call for a halt to hypersonic research, citing the risks exposed by Aurora X's near disaster. Others argue it proves the resilience of modern engineering, urging continued investment. The public, meanwhile, is captivated by the human drama, a story of two souls defying the cosmos to come home. Social media amplifies the emotional impact. Viral videos show the crew's families weeping with joy as news of the safe landing breaks. A grainy clip of the pilot's final radio call, "We're not done yet," becomes a rallying cry, remixed into songs and memes. The incident inspires a wave of interest in space exploration, with young people flooding STEM programs, dreaming of building the next Aurora X. The plane itself, though heavily damaged, is destined for a museum, where it will stand as a symbol of human ambition and resilience. Yet the story doesn't end with triumph. The incident exposes vulnerabilities in the rush to conquer. Hailed as heroes, grapple with the trauma of their ordeal, their private moments of doubt and fear overshadowed by their public valor. As 2025 dawns, Aurora X's legacy is still unfolding. The incident reshapes the aerospace industry, driving new standards for safety and collaboration. The plasma thruster, once a footnote in engineering journals, becomes a focal point of research, with scientists racing to perfect its potential. The crew, now retired from test flying, become advocates for responsible innovation, sharing their story to inspire and caution the next generation. "We touch the stars," the pilot says, in a rare interview, eyes distant. "But we learned the hard way. Space doesn't forgive mistakes." The plane that accidentally ended up in space is more than a headline. It's a saga of human courage, technological hubris, and the unbreakable will to survive. It reminds us that the pursuit of the impossible comes with a cost, but also with rewards that echo across generations. From the Nevada desert to the edge of the cosmos, Aurora X's journey is a testament to what we can achieve and what we must overcome when we dare to fly too high.